So I'm going to look at how electric motors work. Now, I've kind of like looked through the exam papers and tried to figure out 4 things to say if you have to explain how an electric motor works. And I'm going to read them out, then I'll try and, I guess, explain it. So the first thing is that there's a magnetic field because of the permanent magnet. And there's also, when you have a current flowing through this wire here, there's also going to be a magnetic field around the wire. Those 2 magnetic fields interact, just like for Fleming's left-hand rule, and it causes a force on the wire. Now, because the current is going up one side, because the current travels around here, because the current's going up one side and down the other side, we're reversing the current, and so we're reversing the direction of the force on the wire. In this case, because it's like this one for the first one, so this bit of wire is going to move like towards you looking at the screen, and this bit of wire is going to move away from you. Now, that will cause the wire, if you imagine this is my hand as the wire, so this is this bit here, that's going to cause the wire to rotate like this because my little finger is being pushed down, my first finger is being pushed up, so we're going to move like that. But now we get to a point when I actually don't want my first finger to be moved up anymore, and I don't want my little finger to be moved down. I want my first finger to move down and my little finger to move up. So I can kind of keep rotating like that, yeah? So if you take a look at, if you just keep an eye on my first finger, you can see it's going to move up, and then it's going to move down for a rotation. Now the other way of saying that is that the right hand side, so the bit near the North Pole, always needs to be pushing down, and the bit near the South Pole always needs to be pushing up. So what happens is every half turn, the commutator, this thing here, reverses the direction of current so that it can spin continuously, because the right hand side of the coil is always going to be acting, in this case, downwards, and the left hand side is always going to be acting upwards, even though the wire itself is moving around, right? So the commutator has this kind of like a split ring here that means it swaps the current every half turn, and these are the brushes that are just there really to make sure that the wires don't get tangled up. Now, easy to identify a motor because it has a battery in it and it's going to be turning. You have to be careful. It's a very similar diagram to a generator and alternator, an alternator and a dynamo, which I'll go on to next. But this one has a battery or has some sort of supply in, and it needs to be a direct current supply in so that you can get this turning effect. Otherwise, it's not going to work. That's it. Next. This is applied in loudspeaker.